So let's talk about the graphs of logarithmic functions. Like we said in the first video, logarithms and exponentials are inverses of each other, and it shows itself in the graph. And if you can remember if you know the properties of the exponential graph, you can know the properties of the logarithmic graph. And so using the fact that they are inverses, we can get a lot of these things. So let's just make a little chart here. So we have the exponential graph, we have the log graph. And so we can say things, we can talk about domain, we can talk about range, we can talk about asymptotes. So the domain of the exponential, which is the blue one, is all real numbers. So negative infinity to infinity. The range of the exponential is 0 to infinity. And then the asymptote is at y equals 0. So we have a horizontal asymptote, domain's all real numbers, and then the range is all the positive numbers. Now with with the logarithm, because these are inverses of each other, the range is going to be all real numbers, and then the domain is going to be 0 to infinity. So they switch because they are inverses of each other. And then instead of having an asymptote at y equals 0, the logarithm has a vertical asymptote at x equals 0. So this one's horizontal, this one is vertical. So the logarithm will always have, well, any that we're going to see. You can probably think of one, you probably create one that doesn't, but all the ones that we'll see, the logarithmic function has a vertical asymptote. Okay, so let's sketch a graph and let's zoom in a little bit here. So log base 2 of x, and really you want to sketch these. These are kind of choose for multiple choice. But I just want you to notice the ordered pairs of these are the opposite of the y equals 2 to the x. So this would be the inverse of log base 2 of x. And so if you created a table for this one, you would just need to switch the x and the y. And so you can see ordered pair 2, 1, ordered pair 4, 2, the ordered pair 8, 3, and so on. By the way, one other thing to mention on the graph, we could talk about the intercept. Here we have a y-intercept at 1, so 0, 1. Here we have an x-intercept of 1, 0. So like all inverse functions, the ordered pairs are switched, and so the y-inverses become the x-inverse, or y-intercepts become the x-intercepts, and vice versa. All right, so sketch the graph of each function, state the domain, range, and asymptote. And so transformations still work the same. All the same rules apply. So the negative here will reflect over the x-axis. And so instead of coming up like this, it's going to flip upside down like that. And so then the domain is actually not going to change. That will be 0 to infinity. The range is not going to change. That will be all real numbers. And then the asymptote, vertical asymptote, always will still be at x equals 0. So no shifts or anything. So we're not changing any of that. This one, the negative inside, reflects over y, or around y maybe. And so instead of coming up like that, it is now going to come up like that. So we're rotating it around that y-axis. So now the domain is from negative infinity to 0. The range is still all real numbers. And just like with the exponential, the domain was pretty much always all real numbers. With logarithms, the range is pretty much always all real numbers, at least for this class. Like I said, more advanced classes, you can come up with functions where the domain and range are whatever you create them to be. But in this class, we're staying fairly basic, and so the domain and range are not going to, well, at least the range is not going to change on these. The domain we could see, like if we do a horizontal shift, the domain will change. We'll see that in a minute. All right. Last couple of things. Common logarithm. So this is just common logarithm has a base 10. If the base is 10, you don't really have to write the base. So you can just leave it blank. And on the calculator, this is what the logarithm or the log button on the calculator does. So the log button on the calculator assumes the base 10, and then the log with the base e, which is a natural exponential function, that's called the natural logarithm and is denoted by ln. And so you'll see an ln button on your calculator, and so that's what that one is for. Properties of logarithms. So these are pretty much just the same as what we had on the last page, but we're looking at ln. So ln of 1 is 0 because e to the 0 is 1. ln of e, these are inverses, so they cancel each other out. And then the other two are similar to what we saw in the earlier video. So evaluate the following: ln of e to the 8, and you can put these in the calculator, or at least you can put this one in. That would just give you 8. This one, we could rewrite this as ln of e to the negative 2, in which case we're going to be at this property, and that will equal negative 2. ln of 5, there's no way to do this one except, no way to do this in your head anyway. So you need a calculator for this one, and out to 4 digits, you get 1.6094. Usually the ln and the log are right next to each other. ln, if you did the e to the whatever problems that we had in the last section, you know where that button is. All right, and then the last one, find the domain of ln of 4 minus x squared. So we're not going to worry about graphing this one, but it is fairly easy to find the domain of any logarithm function, because you can only take the log of a positive number. So whatever is in here has to be greater than 0. So to find the domain of any log function, all you need to do is set what you're taking the log of greater than 0, and then solve the inequality. So solving the inequality, we get negative x squared is greater than negative 4. Divide by the negative, we flip the inequality. So x is less than 4. Now you could also graph this, but we're going to end up with negative 2 to 2. Now, there are a couple ways you could do this. Obviously, the square root is plus or minus 2. So really, we're just worried, are we between the negative 2 and the 2, or are we outside the negative 2 and the 2? And one way you could do this, you could graph this. I mean, this one is fairly easy to graph. 4 minus x squared would look like that. So your y-intercept is 4, and then of course your x-intercepts are going to be 2 and negative 2. And then where is this one above 0? It is above 0 there. So that's between negative 2 and 2. And you cannot take log of 0. So log of 0 is undefined. So that's why we don't have the equal part here. So whenever you have the domain of a log, it's always going to be parentheses. We're never including these endpoints because you cannot have it equal to 0. Log of 0 is undefined for any base. All right, so I think that's it. Practice these enough to where you get comfortable with using these, because log is kind of an abstract function in the beginning, because you're not used to working with logarithms probably, but you are used to working with exponents to some degree. And so as long as you remember logs and exponents are inverses, and kind of flip those in the appropriate way to get to the inverse, then I think they do get easier. So, but if you have any questions, you can always email me.